Today you will be learning lesson 4.6, or I should say the first part of lesson 4.6 on formalizing relations and functions. And what we're doing in this lesson is deciding if a relation is truly a function or just a plain relation. Okay? So what a relation is any set of ordered pairs. Okay? And now for a set, okay, it's always going to be listed in braces. Okay, so you need to practice drawing those, okay, because you're going to be using them a lot. It's like a bump, a point, and another bump. Okay, other side, parenthesis, better word for it, point, and a parenthesis. Okay, braces. And anytime you're listing a set, okay, it goes inside those braces. Okay, inside a relation and a function, there's something called your domain and your range. Okay? The domain is the possible values for the input of a relation or function. And remember, your input is your x. So it's the possibilities you could plug in for x. Okay? Now this domain is a type of set. So when you list a domain, it needs to be inside of braces. Okay? Same with your range. Okay? It's a type of set. It's a group of that relation or function. Okay? So the range is the possible values for the output of the relation or function, which means it's your possibilities for y. So numbers we could possibly plug in for y. Okay? The trick to domain and range is that they should always be written from least to greatest without repetition. And what that means is if in either one of those sets there's two number 2's, I'm only going to write it inside those braces one time. Okay? That doesn't mean 2 can't be in both your domain and your range. Okay? It can be in both, but it's only listed in each one time. Okay? So in order to decide if something is or if a relation is a function, we have two options. The first one is a mapping diagram. Okay? And in a mapping diagram, or what it is a diagram showing how the input and the output of a set are paired together. It's showing that relationship. Okay? It helps us, like I said, to determine if a function is a relation. Okay? Sorry about that. Okay? So remember, in order to be a function, okay, each input can only have one output. Okay, and that was in, I believe, lesson 4.2, okay, 4.1 or 4.2, where we talked about this A can only have one arrow going from it. This B can only have one arrow going from it. Okay, because this domain, and this is an example of a mapping diagram, right? This A, or this domain, represents our input. Okay, but when you make a mapping diagram, you want to label it your domain and your range. So that domain is your input, that range is your output. Okay, so let's look at one of these problems. Okay, identify the domain and range for the following relation. Okay, so for our domain, okay, remember our domain is a set. Okay, so our domain, I'm going to put those braces. And when I list them, I want them to go from least to greatest. Okay, so I'm going to look here. Here's an X. Here's an X. This is an X. And this is an X. The order pairs are X, comma, Y. The order pair is always your X, and the second number is always your Y. So X is our domain. The range. I see there's two 4.2s. That's my smallest number, so I'm going to write it down. Okay, but I'm only going to write it down once because I don't ever list it twice. Next one, we have a 5 and a 7, so 5 is next, and the last one is 7. So the domain of my function is 4.2, 5, and 7. Okay, the range of our function then is our y values. The range is our y values. Okay, and I'm again going to look from the smallest to the biggest. Okay, so the range I'm looking at 1.5, 2.2, 4.8, and 0. So when I look at those, my smallest range number is 0. Okay, so that one's first. The next one is 1.5. The next one, make sure you can tell commas here, is 2.2. And the biggest one is 4.8. None of them repeat, so I'm going to write them all down. That's the end of my set, so I need to put that braces there. Okay, so domain versus range, your x's versus your y's. Okay, so then it asks me to represent that relation in a mapping diagram and determine if it is a function. So here's the start to my mapping diagram. Remember, the first thing we list is our domain. The next thing we list is our range. Okay, and if we list them over here, okay, making your mapping diagram is not the same as your list over here. Okay, when it asks you to identify that domain and range, it has to be written in a set. Okay, so don't just write it here and say, oh, my domain's labeled right there. That's not going to get you the credit because it has to be inside those braces. Okay, so domain. Okay, when I make my mapping diagram, I'm going to list them the exact same way I listed them in my set. So the first one is 4.2, then we have 5, and then we have 7. Make that look like a better 5 here. 5, and then we have 7. Okay, now my range has 4 values, but I'm still going to list it in that order over there. So we have 0, we have 1.5, okay, we have 2.2, and we have 4.8. Okay, so that's the step one, is to list your domain in your range, okay, in order from least to greatest without those repeats. Okay, the next step to making that diagram is showing how they were paired together. So matching up your ordered pairs. 4.2 was paired with 1.5, so I draw an arrow from 4.2 to 1.5. 5 was paired with 2.2, so I take an arrow from 5 to 2.2. 7 was paired with 4.8, so I need an arrow from 7 to 4.8. And my last order pair was again from the 4.2, which is already up here, over to 0. Okay, so there's my mapping diagram. So then it wants me to decide, is that mapping diagram a function? So what I need to check is, does each input have only one output? If I look right here at 4.2, okay, there's one line and there's 2 lines. So it's asking, does the relation map each domain value with exactly one range? The answer is no, because when I look at 4.2, it has those 2 arrows. And since that's a no, that tells us it's not a function. Okay, and the reason why is because the input of 4.2 has 2 outputs. Okay, so when we go back up to this example one, if I look here, A is only paired with 1, B is only paired with 2, C is only paired with 3, D is only paired with 4. And since they each only have 1 arrow, that tells me that this one is a function. So let's try a couple more of those. Okay, identify the domain and the range for each relation. Represent the relation with a mapping diagram. Okay, so letter A, okay, and I'm going to abbreviate domain with a D and range with an R, and I'm okay if you do that. Okay, domain and range. Okay, again, these are sets, so they need to be listed in those braces. Okay, domain is my x's. Oopsies, that's the same one I just did. So we don't need to do letter A. Already did it. Okay, so letter B. Okay, domain and range. Okay, and if you want to practice this on your own, you should pause the video, right, and try it on your own, and then come back and check your work. Right, domain and range. Domain again is our x. pen is not cooperating with me, so I'm sorry that places look so funny today. Domain is our x values, so we have a -1, a -2, a 4, and a 7. Okay? Remember, they should be written from least to greatest. So the smallest is -2, then I go to -1, then I go to 4, and then I go to 7. And that's every number in my domain. So I put that second brace on there. The range then is my y values. Okay? So for my range, okay, I have a 1, a 2, a -4, and a -7. Smallest values, -7, then -4, then 1, and then 2. This time we didn't have any repeats, so every single number is written down. Okay? Then it wants me to represent it with a mapping diagram. Okay? And when you make that mapping diagram, do not abbreviate that domain and range. Okay? So we need to list our domain and our range. Okay, listed in the set, -1, -2, -1, 4, and 7. My range, -7, -4, 1, and 2. Okay? They put circles around these to show that's your domain. And this one's your range. I'm not so worried about that, but if you want to do it, you can. As long as I can tell they're in a straight line and you keep your mapping diagram nice, you don't need to put those there. Okay? So -2, if I look at my ordered pairs, I'm actually going to start with the first one. Okay? Erase those so we can see them better. Okay? Was -1, 1. So from -1, draw an arrow to 1. Make sure I can tell which number you're pointing to. -2 goes all the way down to 2. Goes to -4, up here, to -4. 7 is paired with -7, so the 7 goes all the way up to the top. And make sure when you're drawing those arrows, okay, if it's kind of messy like this one, that they don't all cross in the same spot. We want to make sure we can tell which arrow goes where. Okay? So when I look at this, okay, and just to show you, not that you put this on a mapping diagram, okay? Use a really light color, okay? Here we have one arrow, here we have one arrow, here we have one arrow, and here we have one arrow. So what that tells me is that this relation is a function, okay? And the reason why, because each input has one output. Diagram. The second way we can tell if a relation is a function is by using our vertical line test. Okay? And we've talked about this in my class before. Okay? This is a second method to determine if a relation is a function or not. Okay? And what we do is we graph the ordered pairs and then we look on the vertical lines. Okay? If the vertical line passes more than one point, then it's not a function, okay? Because when we're drawing vertical lines, our x-axis, if you're looking at the graph here with me, okay, our x-axis, each input can only have one output. So each of these lines is representing a possible input value, okay? So when you're doing the vertical line test, your first step is to graph your ordered pairs. Okay, so my first point is at 4, 2. So I'm going to go over to 4, up to 2. Next one is at 1 and 2. Next one is at 0, 1. Then we're at -2, 2. And then we're at 3, 3. Okay, so using that vertical line test, okay, we need to check each line where there's a dot. Okay? So I'm going to draw a vertical line through each one of those x values. So right there, right here on my y-axis, at the 1, at the 3, the 4. Okay? So it asked, can you draw a vertical line that intersects more than one point? Okay, if I look here, did any of these have more than one point on it? There's 1, 1, 1, 1, 1. So the answer to that question is no. And since none of our vertical lines have more than one point, it is a function. Okay? And the reason why, if it ever asks you to explain, is because it passes the vertical line test. Okay? Again, if you want to try it on your own first, you can pause the video and try it and then come back and check it. That works. If you just want to listen and do it with me, that's fine too. Okay, so is the relation a function? Okay. And again, I wrote the same problem down twice. 4, 2, 1, 2, 0, 1. So we don't need to do A. Okay? So part B. Okay? Start by graphing the ordered pairs. So at 0, we have a dot at 2. At 1, we have a dot at -1. At -1, we have a dot up at 4. At 0, we have a dot at -3. And at 2, I have a dot at 1. Okay? So I'm again going to draw in those vertical lines. Okay? On your homework, you don't actually have to draw them in unless it tells you to. Okay? But I'm drawing them in to help you see what we're talking about. Okay? So, and again, I'm only drawing them where we have points. Okay? So when I look here, here we have one dot. But on this line right here, make that straight. Here, we have 2 dots. And when that happens, it's saying that 0 is paired with 2 different points. So this one is not a function. Okay. To explain, it fails the vertical line test. Specific at x equals 0. Okay, because 0 is paired with more than 2 numbers. Okay, so an error analysis problem. Okay, a student draws the dashed line on the graph shown and concluded that the graph represents a function. Okay, so if I look right here at this vertical line, at that dashed line, there's only one dot. Right? There's only one spot where it crosses. Okay? So she said that it passes the vertical line test and it is a function. At that dot, she is correct. But when I'm doing that test, I need to look at every single spot on that line. Okay? Every single spot, there's a point. Remember, any line, whether it's curved or straight, has infinitely many points. So anywhere that is on my graph, I can draw a line. So if I were to draw a line right here, okay, I were to cross at 1, 2, 3 spots. What that tells me is that that student was not correct. Okay, explain. It does not pass the vertical line test. And I chose x equals 3. You might have chose 2. If I were chose 2, stops there and there. You might have chose 4 here and here. Okay, but I chose 3. At x equals 3. Okay, and what that means is that it's not a function. So the relation is not a function. be working on for today. Okay? Determining if a relation is a function and identifying that domain and the range.